Hi Math 3 students! Today we are going to go over how we can use Desmos to solve equations and systems of equations. So first off, you can make any equation into a system of equations by setting each side equal to y. So like this is when you have one variable, one equation, and you're trying to use Desmos to solve it, okay? So if you take the left-hand side of the equation and do like y equals the square root of 6x minus 12, and then you take the right-hand side of the equation, y equals x minus 2. If you go to Desmos and type in each side into a line on Desmos, it will graph each, and then you can see where these functions crisscross. Where they crisscross is where your solutions are going to be. Now, since this was not a system to begin with, we turned it into a system. All they're asking about is x. So when you are looking at where these functions cross, you're only looking at the x value. If it was a system and they were asking for both x and y, then you would look at x and y. But in this case, they're just asking for x, so we're going to go ahead, look at where these crisscross. We can see that they meet at x equals 2, and they meet at x equals 8. And those are your solutions. All right. So on Desmos, when you graph something, you can go and click where the two functions intersect, and that gives you the solution. Now, you want to make sure that you zoom in very closely so that you don't accidentally click either like an intercept or some other point of interest that you aren't necessarily looking for. So again, you definitely want to make sure that you zoom in and click where they are crisscrossing. All right. Okay, so let's go ahead and try another one here. So for number 2, okay, again, we're going to take the left-hand side, type it in, say y equals, and then we're going to take the right-hand side, do y equals, type it in. All right. So when I do that, this is the graph I get on Desmos. Now, you can see here, especially if you zoom out, these functions actually never end up crossing, right? If you zoom in here, you can see that they don't crisscross at all. So this actually would be no solution. All right, because they don't crisscross. All right, next one. Let's go ahead. Let's try this guy here. So again, you're going to take the left-hand side, do y equals, take the right-hand side, do y equals. Now here's the deal. It is going to graph, your function if you don't do y equals, unless it's just a constant, okay? Like here, if I just do 0, it's not going to graph that, okay? So you have to make sure you do that y equals, especially when you have a constant, or else it's not going to graph it for you. All right, so here you can see that we graphed in red, that's that like 16x squared thing, and then in blue, on the x-axis, that's our y equals 0. So we can go ahead and zoom in and find out where these guys crisscross. And again, we're only looking at the x values. So here we can see that the solutions are x equals -9, x equals -1.5. Oh, sorry, 1.25. Now, one thing you want to watch out for, notice how like sometimes the points will light up because they're just intercepts. Like this is the y-intercept, so that's why it's lighting up there. You don't want to click on that because that's not where they crisscross. You need to look at where the two graphs are intersecting. And here we can see we've got positive 1.25, and then we've got 9. All right. Now, of course, you want to kind of zoom out and make sure that you got all of the points where they crisscross. And in this case, we did get them all. All right. So go ahead. I want you to try number 4 on your own. All right. You're going to go ahead, go to Desmos, type in y equals, do the left-hand side, type in y equals the right-hand side, and figure out where they crisscross. What x value do these crisscross at? So when you graph these, you should see that these guys are going to crisscross at x equals 4. All right. Yeah, they crisscross at 4,6, but again, we're only looking for the x value, so that would be our solution here. All right. Another thing you might be asked to do on the SAT is solve a system of equations. And that's when you have more than one equation with more than one variable. So you were, taught to do this in Math 1 through like elimination, substitution, graphing, and we're going to use the graphing method, but we're going to have the graphing calculator do it for us. All right. So the really good thing about Desmos is it doesn't have to be in standard form. When you like graph on your TI-84, you have to like try and isolate y, because you go to that y equals screen. Now, if you look here at like number 10, these are not in y equals. However, fortunately, Desmos will still graph that for us. So what you do is you just type in each equation. All right, you don't have to separate it into two like we did before. It's already in two for you. So we'll go ahead and type that in. So we'll do negative x plus y equals negative 10. And then we've got 3x plus 4y equals negative 19. All right. And then what you can do is you just need to look at where these two functions crisscross. Now, in this case, it's not like it was just a singular equation like we were solving before. This is a system, and they're asking us to solve for both x and y. So in this case, what we would do is see where they crisscross, and we need both x and y. So it would be 3, negative 7, right? Your x is 3, your y is negative 7. And if you recall, we usually write our answers when it's x and y as coordinate pairs, x, y. All right. So go ahead. I think you can do this one. Try number 11. So for number 11, when you graph this one, we get 2x minus 3y. Whoops. Equals 38. And we've got negative x minus 6 equals y. And again, we're just going to go ahead and see where these guys crisscross. That's going to be at 4, negative 10. So that would be your answer here. Alrighty. Now, sometimes you will be asked to solve something where it's not just like two linear equations. So number 12 is an example of a circle, okay? Now, if you were trying to graph a circle on your TI-84, it's possible, but it is just a pain in the butt to kind of get to the location where it's easy to do that on the TI-84. And again, the nice thing is you could just do this very easily on the on Desmos. All right, so again, we're just going to type in each equation on its own. Squared equals 68. All right, and then we have x plus y equals 3. All right, I think I typed this in wrong. Yes, I didn't type an 8. There we go. All right. So when you type this in, you can see that the first function graphs a circle, and then the second one's a line. Now, it is possible to have more than one solution, right? So you can see here that there are, in fact, 2 solutions. Now, again, I want to point out, notice how it does highlight the intercepts of both of the functions. These are not your solutions, all right? We are looking at where the 2 functions intersect. Okay, so that's going to be at negative 6, negative 6, 9, and 4, negative 1. All right. All right. So, again, today we went over just how to solve different kinds of functions using Desmos. You can solve equations for a single variable using Desmos by taking the left-hand side, right-hand side, separating it into 2 lines. And then you can solve systems of equations where you're solving for both x and y by just plotting both of those functions.